we've got y equals 3x plus 17 and y equals negative x minus 3. In this case, both of our equations are solved for y. We could graph this one, but we'd need some fairly large graph paper since the y-intercept would be positive 17. That'd be a little difficult to graph. So again, we're going to go ahead and use substitution for this one. It looks a little different, but it's actually a very similar problem. Because they're both solved for y, we can actually start with either one of these equations. I'm going to start with the top one just because it's easier for me to work with. So I'm going to take this y equals 3x plus 17, and again I need to put it in place of y. In this case, my y is on the other side of the equal sign. That's okay. So let's go ahead and rewrite that second equation. We want to rewrite the equation that we're substituting into. So let's rewrite that second equation. So I've got, instead of y equals, I'm now going to put in the value that I'm substituting. So I'm going to put 3x plus 17 equals negative x minus 3. I took all of this up here and put it in for the y. So now instead of y equals, I have 3x plus 17 equals. Again, now by substituting in, we've got our equation just in terms of x, rather than having an x and a y. And because of that, we can now solve it. So let's bring our x's over to the left, get our variables on one side and our constants on the other. 3x plus x gives us 4x plus 17. On the right-hand side, we're left with negative 3. Move 17 to the other side. So we've got 4x equals negative 20. Dividing by 4, we get x equals negative 5. That's half of our answer. Again, let's go back up to the top. Okay. In this case, they were both solved for y, so you can use either one. They're both fairly simple to substitute back into. I'm going to use that top one. Y equals 3x plus 17. So as I substitute back in, we had negative 5 as our value for x, so I'll plug that back in. 3 times negative 5 is negative 15. Combining those like terms, negative 15 plus 17 is 2. So our final solution is negative 5 and 2. In section 6.1, we solved systems of equations by graphing. However, sometimes graph paper either isn't available to us or isn't the most convenient method for solving a system. In this case, we have two equations, one of which would be fairly easy to graph, the first one, but the second one we would have to solve for y, and it might be more difficult for us to finish that one by graphing. So in section 6.2, we're going to look at solving by substitution. And in substitution, it's easiest to use that when one of your equations is solved for a variable, like the first one, but the other one is not. This one's in standard form. Substitution means you're going to substitute one equation into the other. So I'm going to take this first equation. I've got y equals 3x minus 3. I'm going to take all of 3x minus 3, and I'm going to substitute it in for the y in our second equation. Okay, so I'm just going to draw this green line here to separate it a little bit. So my new equation is 2x plus, but instead of this y, I'm going to put in 3x minus 3. And then equals 17. So just to clarify, I took this y and replaced it with 3x minus 3. So my equation is now 2x plus 3x minus 3 equals 17. Now I have an equation that's pretty simple for me to solve for x because I'm down to just one variable. Instead of having x and y, I have all x's. So let's go ahead and solve this one. I can go ahead and combine like terms. 2x plus 3x gives me 5x. So 5x minus 3 equals 17. And then we can begin to solve. Add 3 to both sides. 17 plus 3 gives us 20. Divide by 5. And we find that x equals 4. Okay, now that's only part of our answer. If you remember when we graphed, we always came up with an ordered pair, x and y, that gave us our solutions. So in order to find y, we need to go back to our original equations and find the other variable. Usually with these, it's going to be easier to use the equation that was already solved for y. So I'm going to come back up here to the top. And I'm just going to rewrite this equation because it's already solved for y. So we've got y equals 3x minus 3. So now I'm going to plug in my value for x to find what y is. So I'll do 3 times 4 minus 3. 3 times 4 is 12. So 12 minus 3 is 9. So my solution, remember that we always do x and then y, so our solution is the point 4, 9. Okay, let's look at a second equation. We've got negative 4x plus 4y equals 8, and y equals negative 2x plus 5. We're going to use substitution again because we have one that's in standard form and one that's already solved for y. So substitution is going to be our best choice. So since this one is y equals, I'm going to take this negative 2x plus 5 and I'm going to substitute it in for the y in the first equation. Let's see what that looks like. So I'm going to begin rewriting the first equation, but when I get to that y, I'm going to plug in this value instead. So I've got negative 4x plus 4, and in place of that y, I'm going to put negative 2x plus 5 equals 8. So again, just to clarify, this y right here became negative 2x plus 5. I just rewrote that first equation, but substituted in a new value for y. Again, this is an equation that should be fairly easy for us to solve, so let's just begin to work our way through it. We've got negative 4x. We've got to use our distributive property for this one because we had multiple terms in here to work with. So 4 times negative 2x would give us negative 8x. 4 times 5 is 20. Equals 8. Combining like terms, we end up with negative 12x plus 20 equals 8. Now we're ready to begin our solving steps, so we'll subtract 20 from both sides. We get negative 12x equals negative 12, so x equals 1. Again, that's only half of our answer. So let's go back up to the top here. And if you remember from the first example, I said it's easier to use the one that's already solved for y. So in this case, it's the second equation. So I'll take y equals negative 2x plus 5. We're going to plug in the value that we just got for x. So we figured out down here x equals 1. So I'm going to put 1 in for x. Negative 2 times 1 is negative 2, and negative 2 plus 5 is 3. So our solution to this system of equations is 1, 3. That is the point that when plugged back into either one of these equations will make that equation true. It's the only point that works for both equations.